Hi, in this video I want to talk to you about the two different formats that your quadratic equations might be given to you in and how you can extract information out of them regardless of their form. So the first one is the standard or vertex form, so that's what I want to look at first. If they ask you to find the vertex and you're in the standard vertex form, it's actually a fairly easy question. We can pull that information right out of it. The point HK is indeed our vertex, so I can just pull that out. In that case, that's 2, 9. Not a lot of work to be done as long as I know that that's how that form works. Now, if it's given to me in expanded form and they want the same thing, don't try to take this expanded form and rewrite it in the standard vertex form in order to do it. That's too much work. We have a different technique we can use. We have that vertex formula that tells us that the x value of our vertex can be found by doing negative b over 2a. And we're now in the format where we know what a, b, and c are. So this would be my preferred technique here. It's going to get me there faster. I can do the opposite of b over 2 times a. I can find 12 over 6, which is 2. That is then the x value of my vertex. If I have an x value and I need to find its matching y, all I need to do is sub that back in. So I can do y equals 3 times 2 squared minus 12 times 2 plus 21. See, that will give me 3 times 4 minus 24 plus 21. 12 minus 24 plus 21. 12 minus 24 is negative 12 plus 21. Which happens to be 9. So there's my vertex in this format. Okay, what if they asked me to find the y-intercept? What I need to know in both cases to find the y-intercept is I need to understand that y-intercepts look like 0, some number, where I go 0 over on the x and I land up or down somewhere on the y. So no matter which way they present the equation, what you want to do is you want to go in and put 0 in for your x, find y. Oops, plus 9. So let's see, y equals, this is all going to, that's a negative 2. Negative 2 squared is 4, so 3 times 4 plus 9. So y equals 12 plus 9, 21. So it looks like my y-intercept is the point 0, 21. Okay, let's see how that works on the other side here. So on the other side, if I do the same technique where I put in zeros, for my x's, then both of these drop out. I'm left with only 21. I get the same answer. Okay, now what if they ask me to find the x-intercept, or the x-intercepts? I start off with the same basic knowledge that x-intercepts look like some value, 0. Where I go left or right some amount, but I don't go up or down at all. So I need to go in and I need to let y be 0 in either case, and then solve what I have left. Okay, at that point, my technique is going to be different based on the two formats. So on the right hand one, I'm going to do this one first this time, just because I really happen to love the quadratic formula. So this one is set up where I know A, B, and C. It's lending itself great to do the quadratic formula. The quadratic formula calculates x-intercepts by employing the formula negative b plus or minus the square root of b squared minus 4ac all over 2a. I just have to sub it in and go for it. So let's see, the opposite of b is 12 plus or minus my equal to sign got a little crazy there. The square root of b squared minus 4ac all over 2 times a. Let's see, this will be 144 minus whatever 12 times 21 is. Uh-oh. All over, let's see, I randomly made this one up, so I really am doing this not knowing what the answer is going to be. All over 6. But what I notice in here is that this is negative. So I can't take the square root of negative numbers, so it looks like I have no real solutions. It appears as though this is not going to actually cross the x-axis anywhere. Let's see if I run into the same problem over here, because what you might have noticed is this is actually the same exact parabola, just in a different format. So what if I start solving, I forgot I already have it set up. So what if I start solving this one? On this one I would subtract 9 to the other side. And then I would divide by 3. I'm trying to get to that x. And at this point, I would try to take the square root of both sides, but I would get stuck in that exact same situation where I'm trying to take the square root of a negative. So I would get stopped in my tracks here as well. It doesn't look like there are any x-intercepts. Once you know some of these key features, you should be able to sketch a graph based on either one of them. So let's think about what this graph is actually going to look like. It told me that my y, or let's do the vertex first. The vertex is at the point 2, 9, so over 2, 9. So here's my vertex. Then it says it crosses the y-axis up at 21. So this is 9. It crosses the y-axis up here somewhere. That's enough for me to draw this parabola. If this is the middle point, it's only going to go up from there. So now I can definitely see that this all makes perfect sense. Why are there no x-intercepts? Well, because it started above the x-axis and it continued to go up from there. So you can kind of put all of those things together and double check your work. I was a little bit startled. It was just a question that I totally made up. I didn't realize it wasn't going to have any x-intercepts until I got to that point. But now when I visualize it, I'm perfectly fine with the fact that I got that. It makes complete sense when I put all of that together. So just be careful about the format that they've given to you and don't make your life harder than it is. Use the technique that lends itself to that formula. When you've got A's, B's, and C's available to you, use the Vertex formula and use the Quadratic formula because it relies on those things. If you've got the standard Vertex form, use that Vertex idea, because that's the presentation that's given to you and you can do it a lot faster. Don't try to fit one form to a different formula. You're just going to do a lot of extra work.